Okay, so we just solved the first system of equations by substitution. What I like about these methods is that you look at the name of it, and you understand your vocabulary and understand what substitution and elimination means. It means just that. Instead of substituting for one of the variables, we're going to eliminate one of the variables. And by doing that, what we want for the two equations, what we have now is 2x plus 3y equals 18, represented by the red line, and 2x plus 5y equals 10. So we want to eliminate one of them. And to do that, we either add or subtract. To get rid of one of them, and when we look at the two equations, we need one of them. When we look at the two equations, we want the terms to be the same, either positive or negative, because we can either add or subtract the two equations from each other. And that's what we're going to be doing by eliminating, is adding or subtracting. And to do that, when we add or subtract, we want one of the terms to be eliminated. So if you look at there are two equations, 2x plus 3y equals 18, which is represented by the red line, and 2x plus 5y equals 10, represented by the blue line. We look at it and we see that 2x is the same in both of them. So since they're both positive, if we subtract one from the other, or when you subtract, you can multiply by 1 and then add. So what we're going to do is, since it's 2x, we're going to multiply the whole thing by minus 1. Okay, and that, of course, needs to be distributed to each term in the equation, which are separated by plus, minus, or the equal sign. So we multiply by each term, so we end up with the first equation staying the same. I'm not going to do anything to that. And then distributing the minus 1 in the second equation. So minus 1 times 2x is minus 2x. And then times 5y is negative 5y. And that equals to a negative 10. So now we just add. These, of course, cancel out. Makes 0. 3y minus 5y will give you minus 2y. And 18 minus 10 is 8. So to isolate the y, we continue, divide by 2. Or we want to divide by the same thing, so it's a minus 2. So these cancel out, and you're left with y equals negative 4. So once we get what y equals, that is not the answer yet. We're going to substitute that to either of the two equations. It doesn't matter. I'm just going to pick the second one arbitrarily. So it's 2x plus y. I'm starting over here on the left side to give me some more room. And we're going to substitute for y. So I like to put parentheses in case I have a big term I'm putting in there, equals 10. And that's going to be minus 4. So solving for x, 2x 5 times minus 4 is minus 20 equals 10. And then we're going to combine the like terms, which are the constant. So I'm going to add 20 to this side, which is the opposite, and do the same thing on both sides. And I get 2x equals 30. And then divide by 5. Or 2, sorry. These cancel. And x equals 15. So the way to write that solution is as an ordered pair, which means you have your pair separated by commas, and x is 15, and y is minus 4. And that's your answer. So if you look at the graph, we go 15 to the right, starting from the origin. And I'm just going to do this in green. We go 15 all the way to the right, and then down minus 4. 1, 2, 3, 4. And that is a solution we came up with algebraically, and it matches the graphical solution. So all these equations can be solved by graphing, by substitution, and by elimination. But the method you choose is up to you, and usually you choose it by what's given to you. If you have similar terms that you know you can eliminate one by adding or subtracting the two equations together, then you would use elimination. And if you already have something where it's like x equals 3y or y equals 2x plus 5, you can just substitute it in the second equation for that other variable. But without further ado, the answer to our riddle is you shouldn't be intimidated by math because it's really easy as pie. Thank you for tuning in. If you have any questions, feel free to send me a message or ask me in class. Thank you.